Good afternoon, folks, and thank you for joining us. My name is Yavor, and I work on the Azure Application Platform team. In the next 50 minutes, we're going to talk about Node.js. What is Node? How do we host Node applications on Windows Azure? And what's the future direction that our team is going to take? That's roughly the structure for my talk. We're going to do three big sections. First, kind of cover what Node is, the value prop, then talk about Node on Azure, and then discuss the future direction. If you have any questions as I go along, please use the Channel 9 hashtag on Twitter to go ahead and type your question. I'll try to answer it as I go. Okay, so without further ado, let's jump into it. So what is Node? Node is a cross-platform runtime for writing distributed network apps. And it's JavaScript. So it uses Google's V8 JavaScript engine, which is small and lightweight, to host these small, fast network applications. It's cross-platform, so it runs on Windows, Mac, and Linux as well, and it runs at scale. It can handle a very large number of concurrent users on a single machine. It's an asynchronous runtime, and it's single-threaded, which has some nice side effects. Like, for example, the fact that you never have to worry about locking in your code. That's kind of a nice side effect of being single-threaded. Also, because you're running on a single thread, you only need to worry about a single stack allocation. So your memory footprint is fairly contained when you're using Node. And if you have multiple threads on your CPU, which most people do these days, like 8 or 16 cores, there's actually ways to scale Node out to more than one instance, to more than one thread. But in essence, it's a way to write distributed network apps in a way that massively scales without eating up too much of your machine resources. I want to emphasize the threading aspect a little bit more because it's quite interesting. So on the left of your screen, you see the one single thread that Node is always using. And there's a bunch of resources that the thread needs to talk to do I/O. For example, database drivers or the HTTP stack. But these are external, and they don't ever block the main thread. So for example, if an app dispatches a set of requests, if a request is CPU bound, like number 1 here, it'll go to the main thread, it'll get executed right away, and it will return. Now, the second request here is actually a database operation, so that could potentially block. So the thread needs to pass it off to the database driver, and it could block here and wait, but that's not how Node works. It'll actually register for a callback. It'll ask the database to queue up the results at the end of the work queue, and it'll actually proceed with the next task in the queue without blocking, without waiting for the database to return. When the database is ready, it'll queue up its results in the queue, and they'll get picked up in the right order. So this way, the main thread is never blocked. Now, let's see how we actually express this in code. This is the Hello World Node application, which we've taken from the Node.js website, and it's pretty straightforward. It's a HTTP server that just prints out Hello World to every request that it receives. If we analyze through the code a little bit, so first we see this require statement, which basically tells Node to bring in the HTTP module, which we're going to use. Then this create server call sets up the HTTP server, and then at the end we say .listen, and we give it a port. So that's the port on which the Node HTTP server is going to listen. What's in the middle of the method here is this function is actually a callback, and this is a callback that will execute every time there's an incoming request. At the end, we say console.log, and at this point, our application is actually off the thread. We've registered a handler for HTTP, and we've gotten off the thread. Now, every time there's actually an HTTP request, this function is going to fire. But other than that, a Node can process other tasks in the meantime. We're not blocking the thread. So inside this actual callback that you see here, we do something very simple. We just set the content type and write out hello world. That's all this does. So this is your first Node application. Very simple, very straightforward. Now, I hinted at the fact that Node uses modules, so let's dig into that a little bit. The core of Node is just the JavaScript engine, and all the external functionality has been split out into modules. So HTTP I already showed. It's one of the most robust and frequently used modules. But there's others as well, the FS module for the file system operations, the net module for sockets, and then the crypto module as well. And modules can be the core modules that are part of Node itself, that are bundled with the Node download, which is something like 5 or 6 megabytes is the actual Node process. So they can be either bundled with that, like the modules I just listed here, or they can be external from the Node module registry, which has currently about 9,000 modules on there. So your app can mix and match and use any of those. But the key here is that Node itself is kind of designed with modularity in mind. Node, if you're curious, it started actually just a few years ago in 2009. It was created by Ryan Dahl, who now works at Joyent, and Joyent is kind of the ongoing sponsor of the Node project. But Node is now coming to Windows Azure as well, and we're looking to build first-class support as well. And we're seeing really sort of good signs that Node is actually picking up in the community and in the enterprise. If you look at GitHub, it's actually the second most followed repository on GitHub. And we're seeing enterprises start picking it up as well, like Walmart and Yahoo. A lot of mobile apps actually being built with a Node backend because of its distributed nature, and because of the fact that it's fairly lightweight. So I already mentioned it's kind of good for these network apps, but let's be a little bit more systematic here. If you're writing something event-driven, something that, for example, requires a massive number of clients or WebSockets support, something like a chat server, something real-time, then Node's a really good fit for that because the threading model, the small stack, all those things that I mentioned. Also, the fact that it's JavaScript makes it super convenient for returning JSON data. It also makes it super convenient in the case where you want a server app and a client app to actually share the same logic. For example, if you have business rules or validation that's used between the client and the server to enforce a certain rule. So these are all scenarios for Node apps. I mean, for great Node apps. It's basically kind of a resurgence of the thick client. We've started building now again thicker clients in JavaScript, clients that don't necessarily come with any static HTML to begin with, and kind of they're dynamically built up through JavaScript. And that's kind of the sweet spot for Node. You'll see in my list of maybes, I've listed sort of straightforward CRUD or static content apps that you typically build with something like ASP.NET MVC. It's not that Node is not good for these applications. In fact, many people put up websites hosted by Node and blog engines and stuff like that. But you don't benefit from the massive scalability characteristics as much in that case. So that's why it's a maybe. What Node is not a particularly good fit for, and some people will argue with this, but that's my take on it. What it's not a really good fit for is sort of CPU-bound applications that really sort of require a lot of horsepower, something like a video encoder. For an application like that, I would probably choose, a compiled language, something like, C or C#, because JavaScript, as good as the V8 engine is and as fast as it is, it's still an interpreted language. It's not actually compiled down. So I'd pick a compiled language for that. So I alluded to the fact that there's actually a large repository of external modules as well, and there's a very vibrant community around that. The package manager is called npm, and it's available as a command line tool when you install Node itself. And the module registry lives at npmjs.org, which currently has something like 9,000 or more modules available. And it's a very healthy ecosystem. I've listed on this slide the top modules that almost everybody in the Node community is using. Connect is a good HTTP middleware module. Express is a very popular web framework for static content, static or dynamic HTTP content. Socket.io is very popular for developers that are trying to use WebSockets or long polling to do a chat application or any sort of bidirectional communication. And it has this concept of gracefully degrading between a WebSocket transport to a long polling transport, which makes it ideal for challenging connectivity situations. Further down the list, we have MongoDB, which is the kind of the canonical NoSQL solution. So there's a driver for MongoDB, so you can use it from Node. Redis is an in-memory cache, which pairs nicely with these real-timey scenarios with a large number of clients. So it's a good in-memory cache. JS DOM lets you generate HTML DOM and parse it. So these are kind of the things in your tool belt that you find yourself using quite a bit in writing your Node applications, and I'll demo a few of them right now. So let's jump to the command line here. The first thing I'm going to do is just actually invoke the Node executable itself. And I'm given this eval loop environment in which I can type in any Node command that I want. So I can start with console.log and then just do a hello. And it echoes it back for me. That's pretty straightforward. Let's do that first Hello World app that I showed in my slides. Okay, so let's copy paste the code from my slide. I need to purchase a full license of Sublime Text at some point. It's actually a really good text editor that a lot of people on the team use. So let's go ahead and actually run this application. So I already talked you through the code, so let's just say node and then pass hello.js. And that's how simple it is to spin up my first HTTP server using Node. Let's go ahead and actually try it out. Okay, and as we see, as expected, we get kind of the hello world response back. Great, so let's move beyond this first trivial application. Let's actually create an application using the Express framework, a simple HTTP application. So I'll create a folder for my application, and I start off with an empty folder. Let's first bring in Express from the Node package manager. I'll type npm install, and then I'll type Express. I'll pass the -g flag to the npm install command because Express actually comes with a nice command line tool, and if I pass the -g flag, it actually installs Express globally on my machine, and I can take advantage of the command line tool that it offers. So it'll go out to the actual package manager and it'll download Express itself, and I'll install it on my machine. That's a pretty straightforward process, and this is how I'd get any other module, including any of the other ones I showed you, like Socket.io or the Mongo driver, any of those things. So it's ready. It has pulled down Express on my machine, so now I can use the Express command line. So I'll just type in Express, and it actually scaffolds out a bunch of content for my first Node application. I don't even have to look at it. I see that I have an app.js, so I'll go ahead and try and run that. Now what's happened is Node has actually returned an error saying, well, great, but where is the actual module? So we need to go ahead and actually install the Express module. What I did before with the global install, I just didn't actually install just the command line tool, but the module itself needs to be present in the app. So I could type. I could install the modules one by one, but Express actually already created for me this package.json file, which is kind of like a manifest for the modules that it needs to use. So if I look at that, you see it actually says, okay, download Express and download Jade, and Jade is the view engine that it's going to use. So I could type manually. I could do npm install Express and then Jade, and this would pull them down. But the package.json is a nice shortcut, so if I just do npm install, it'll use whatever is in the package.json and download those dependencies. So I run npm install, it'll bring in Jade and Express, and then at that point I'll be ready to actually run the app. So I'll show you further on. There's an example actually where I use Socket.io as well. But okay, so I have the Jade and Express modules installed locally, and you'll notice it's created this Node modules folder as part of my app, and that's where the actual modules will be stored. So now I can do node app.js. Okay, and I see the Express server has been initialized. If I go ahead and see port 3000, I see that my first Express application is running. Okay, so we can go ahead and actually install other modules as well. So I can install Socket.io, like I said. So I'll just type npm install Socket.io. It'll go ahead and fetch those bits and put them in that same Node modules folder. So far so good. We have kind of a basic Node application working locally. We haven't involved Azure yet at this point. We've just talked about Node and the package manager. So let's come back to that in a minute. Great, so we showed Node, we talked about the value prop, when is it useful, kind of what are the benefits, what are the downsides when you wouldn't want to use Node. Let's talk about Node on Azure. Now, the first thing we should say is that the fact that we're talking about Node doesn't mean that you need to start rewriting all your applications in Node. In fact, I was very clear in stating that Node is actually useful for some scenarios around real time, but not necessarily kind of a catch-all for anything you might want to build in the cloud. It's not the strongest thing when it comes to HTTP. So we see a lot of customers actually building an ASP.NET MVC application and kind of augmenting that with a Node server for their mobile clients. So these kind of hybrid scenarios are actually very popular. So you don't need to wholesale switch to Node. Just look at Node as kind of an answer to the scalability challenges your app might be facing as you add multiple clients, and use it as appropriate. But if your existing tools like ASP.NET or PHP are doing the job for you, there's no reason to switch to Node unless you really need it. So the actual Azure integration is these three pieces which you see on this slide. The first thing is IIS Node, which is sort of the glue that sits between IIS and the Node process itself, and gives it sort of some nice characteristics. IIS knows how to activate processes when a request comes in. It knows how to keep things alive if something crashes. So by using IIS Node, we get these benefits. We sort of manage the lifetime of the Node exe instance, which is something that it doesn't do out of the box. So that's IIS Node, and it's a GitHub project available under an open source license, so anybody can go and look at that. We also offer a bunch of libraries for the most common Azure services. So if you're a Node developer who wants to write an application that talks to table storage, it's fairly easy to pull in our package and talk to Azure services. And again, these are on GitHub and open source. The last thing on that list is a set of PowerShell tools, which I'll demonstrate in a minute, which let you deploy your application to Azure. A lot of Node developers don't actually use full-scale IDE, such as Visual Studio, to deploy their apps. Many developers are used to just pushing their apps to the cloud from the command line, and that's what these PowerShell tools do. Now, you don't actually have to go to GitHub and build these from source or anything like that. You can just go ahead to this link at the bottom of the screen here and get a web API feed that contains all this, and it'll set up your machine for you. So let's talk for a minute about IIS Node. IIS Node is, like I said, the glue piece that sits between IIS and the Node instance itself. And we only use it in web role because that's the only role that uses IIS in Azure. The actual implementation of IIS Node is as a native module, and it knows how to scale up to multiple threads. Like I said, if the CPU has multiple cores, it makes sense to scale out to multiple threads, and it will do that for you. So that's one of the nice things you get with IIS Node in web role. In worker role, we've kind of left more control to the developer. So we don't use IIS or IIS Node. We just basically create a single Node exe instance and run your code against that. The downside is if something goes wrong, we're not going to restart Node for you. You might end up in a broken state. The upside is that you get a lot more control. You can actually deploy a lot of the solutions that Node itself offers to be able to restart itself or to spin out to multiple threads. There's a cluster module that's available for Node, which is a very commonly used module to accomplish scale out. There's a bunch of other ones that let you kind of handcraft and build your own sort of environment in which you run Node and kind of control the elasticity and scaling of it. So if you want that kind of control, worker role is a pretty good fit for you. Again, talking about IIS Node a little bit more, like I said, I already mentioned the fact that it does the process management, the lifetime of the process for Node itself. It will scale out to multiple cores. It'll actually let you host a Node.js app side by side to an ASP or PHP file in the same web role. So it actually knows which files are Node and knows to run them against the Node process. But if there's something that can be handled by ASP.NET or PHP, it'll actually leave that alone. So this is how you can accomplish the hybrid scenario, where you integrate Node with an existing app. It offers also support for Node Inspector, which is a popular way to debug Node applications. It's able to capture your logs and store them for you so you can get back to them later if your application crashes. It restarts your Node process if you actually touch some of the Node files, which is particularly useful in a development scenario when you're developing on your local machine. It also catches some of the Node runtime errors and displays them in a nice HTML page, so you can easily, similar to custom errors in ASP.NET, so you can easily see what's going on. So offers all these nice features on top of just the bare bone Node process. The next piece after IIS Node was the actual client libraries we offer. So I said just like any other package, you can install these by typing npm install Azure. Just like I installed Express, I typed npm install Express. I can do the same thing with Azure libraries. And today we support blob, table, queue, service bus, and service runtime. Of course, we're constantly working to add new libraries to support more and more Azure services. And the good thing about these libraries is you don't have to be an Azure hosted application to be able to use them. You can actually run your application locally on your machine and take advantage of Azure tables. But the most common case, of course, will be people writing applications, hosting them on Azure, and using Azure services. The link at the bottom of the screen takes you to the Azure Developer Center, where we have how-to documents on using each of these packages with detailed examples. And with that, let's jump into sort of a more comprehensive demo that actually shows how we take an app and how to a regular Node app and get it ready for publication in Azure. So I've already pre-created this folder here to save some time. And you'll notice it's basically very familiar to kind of the existing web role, worker role structure you're familiar with. What I did to create this is I used the new Azure Service PowerShell command, and this is where the PowerShell commandlets that I described come in to let you easily scaffold out and deploy your application. So I ran new Azure Service and it scaffolded out this folder. After that, I ran add Azure Node web role, and you notice the really nice IntelliSense on PowerShell, which is really helpful, especially with the longer command names. And that's how this web role 1 folder got created. And knows how to hook up, all the definition files and all that stuff is taken care of. And so once the web role folder was created, I can actually go ahead and drop my Node.js application inside of there. So if you look carefully, you notice we have kind of the views folder and the routes folder and the controllers folder. So this looks like an Express application, and that's what I actually used. So let's go ahead and do a simple walkthrough of what the app actually does. So notice I'm using Node again, just not using any Azure integration yet. So let's go ahead and see what the app does. For some reason, Chrome hasn't been that good to me today. So let's switch to IE. So this is a simple application. It brings together two sets of features. One set of features involves Facebook, and it actually uses Facebook to authenticate and uses my friend graph in Facebook to bring in and populate the list of users for the app. The other part uses Azure Table Storage to actually store these tasks. So for example, my friend Aaron, I've assigned a task to him called Give Presentation. So that the task itself is stored in table storage, and Aaron's name comes from, and picture comes from the Facebook social graph. I can go ahead and log into the application using Facebook. And I think I'm already logged in, so it just came right back. And now that I'm authenticated, I can go ahead and complete an existing task. Or I can create a new task and assign it to anybody here who's my Facebook friend. So on the high level, that's what the application does. And so far, I've been using just regular Node to run this application. Let's go ahead and actually let's actually go ahead and take a little bit of a more deep look into the code of the app. The most interesting thing here is if we actually go inside the controllers folder. And read through this tasks controller. And this method actually is very revealing as to the way you would structure Node code. And let me remind you of the fact that it's all asynchronous and there's basically no blocking calls anywhere in the application. So that requires sort of a particular way of structuring my code. So a good example here is actually if I bring in this get Facebook friends method. So you'll notice it actually takes some information, a token, and then instead of just returning my friends, it actually takes a callback. And you notice this callback is used throughout the application. So this way, this method can actually use a closure to delegate that callback to a subsequent call. For example, here you'll notice it's actually calling out to the Facebook Graph API, and then when that returns, only then does it return my data back through my callback. So this is the implementation of an evented model that Node gives you, and it's a little bit scary at first. You end up writing a lot of spaghetti code with a lot of nested callbacks, but as you get more structured about how you write your code, it actually starts getting quite nice. So you'll notice in this case, basically, I send a call, this session .graph call. That line actually goes to Facebook and gets my friends. If there's an error, I'll pass that to the callback. If there's a success, if the call succeeds and it gets my Facebook friends, I'll sort them and then I'll pass them to the callback. So that's a nice example of a Facebook function, of a Node function that talks to Facebook and uses callbacks. Now these functions are actually my controller functions that return data to my views. This one is particularly interesting because I actually have to do two parallel calls. So this is the call that will bring together the Facebook friends and the task information from Azure. So I need to dispatch both of these calls at the same time, wait for both of them to complete, and only then can I actually render the page. And you'll notice I'm actually using the async library. It's an NPM package, and I'm actually dispatching the call to friends and the call to tasks in parallel. Now, when both of these complete, this actual handler here aggregates both the callbacks, and then I can use the data from Facebook and sort of mash it together with the data from table storage to produce the final data that my view needs. And so this is similar to sort of TPL stuff that we have in .NET, and it's also available in Node. It's super helpful, and that's kind of very common as you start to leverage packages that are available in the package manager. You start simplifying and ripping out large chunks of your code. That's one of the most rewarding feelings when you're working with Node is there's such a strong community, and a lot of the stuff you need has already actually been implemented way before. So let's go and look at some of these other methods, and in particular, let's look at actually I can scroll back here. Let's look at the use of the Azure module, the module that Microsoft actually ships. If you look at this code here, storage client is actually something that we ship as part of the Azure module. And it contains a query entities method. It takes a query, and this is the format that we support. It's sort of an impromptu link style format. So we can say, select from this given table all the tasks where completed is equal to false. So all the tasks that are still active. So that's pretty much how you use that. Again, you pass a callback, and when the call to Azure returns, you can go ahead and that callback will fire. It'll return the results for you. Now, here's another example. So this is the new item method in which I actually go ahead and add a new task to my list. So we can go ahead and sort of ignore this part here because I need the Facebook name of the person I'm about to assign the task to. So I do a little call out to Facebook first to get the name. But the usage of the Azure module is actually right here. So you'll notice the storage client.insert entity method, and that's the method that I would use to actually add a new row to my table. So I pass the table name, the item, which you see I've built up. I've added assigned to name, completed equals false. So I've already built up this item, this JavaScript var, and then I pass it to my insert entity method and it makes it into my table. When the call to the table service returns, I get this entity inserted callback, which I can check to see if the insert was successful. So if the error is not null, or if the error is null, sorry. If the error is null, then I know everything succeeded, and so my entry made it into the table. So I can go ahead and render the page. Another interesting usage here of the Azure API is this complete method on my controller. So this is when I press complete next to a given task. It needs to go out to Azure Table Storage and update that one row. So you'll notice here that I first query for the entity I need. Again, we have the callback, entity queried. It goes ahead and returns that to me. I set the completed flag to true, which is the whole point of completing something. And then I use the update entity method to actually pass the entity back and store it in table storage. So hopefully this gives you a little bit of a glimpse of sort of what our modules are capable of and how you would actually use them. At first it's a little bit difficult to get used to sort of the callback nature of Node. But at some point it becomes sort of second nature to any Node developer, and you sort of stop noticing it. And if you can't stop noticing, there's helpful methods like the async, helpful packages like the async package I showed, which kind of helps you get out of that a little bit. Okay, so we showed this application, we ran it against Node, we walked through some of the code to see what it does, but we still have not talked about how do we publish it to Azure. I talked about kind of creating this scaffolding. I used new Azure service and add Azure Node web role to create the folder structure here. How do we publish? Well, the first thing we should always do before publishing to the cloud is actually run things in the local emulator to make sure everything is working correctly. So I can actually go ahead and say start Azure emulator anywhere in this folder here. And it'll actually package up the application and run it against the same emulator that we'd use for .NET or any other application containing web roles or work roles. So we've integrated with that, and it's it's pretty seamless and pretty close to the kind of environment you'd get in the cloud itself. So pretty high fidelity sort of emulation experience. And that's kind of a big differentiator for Azure. If you look at a lot of the competitive hosters for Node, there's actually very rarely sort of a local emulation environment. A lot of the times you have to sort of push to the cloud repeatedly. For Azure, you actually have this local emulator that you can try. So let's see if our app still works in the local emulator. I'm not going to run through it, but as you see, basically it comes up. Everything looks okay. So now let's do the. Actually, let me show you a little feature here, which I omitted last time. If you go to the chat tab, we actually show Socket.io as well. This app is kind of nice. It shows a few Node packages. So I can actually open two browser windows here side by side. And this is, again, that Socket.io module, the one that lets you do sort of bidirectional communication between two clients. So here are my two modules, my two instances of the app. They're running in the emulator, and I can go ahead and start sending messages across. If I type hello here, it'll be visible in the other instance, and vice versa. So this is what that Socket.io module gives you, and it's kind of a good example for the kinds of applications you would want to build with Node. Okay, so let's head back to the slides here. So this application is actually available on my GitHub account, so you can go ahead and clone that repo and play with it, deploy it to Azure yourself. It's all available right there for you. And with that, let's spend a little bit of time actually talking about the future direction. And this is a place where you could actually significantly contribute to where we're going with our product. And so I'd appreciate any of the feedback via Twitter or via email later on. I guess the first thing on this list is kind of a faster and easier deployment experience. Web role and worker role is kind of a heavy VM a provisioning unit. So when you actually create a web role, there's a VM that gets provisioned in the background, and that's different from what a lot of our competitors are doing. So there's there's the opportunity to really innovate in Azure and kind of try to create a lighter weight experience, similar to sort of the shared hosting experiences that our competitors have. As a data point here, let me actually go ahead and start the deployment for my Azure application. I'll use the publish Azure service command. And this will go through the regular Azure provisioning flow. I just have to specify a unique name here. Let's use something numeric like that. And this will start the the Azure provisioning flow. And you know, this takes something like 4 to 6 minutes, and it's something that we're not super proud of, and we'll try to get to improve in future versions. I'm actually not going to wait for it to finish because it takes a while. But eventually, once you go through this process, you get the copy of your app up in the cloud. So when we talk about a lighter weight deployment story, we're talking about kind of accelerating the deployment to the web role. The second item on this list here is the actual tooling aspect. So you saw I use Sublime Text to develop my application, you know, that's great. Sublime Text is an awesome editor for Node, and it's incredibly popular in the community. We're looking at actually improving Microsoft tooling as well. For example, Visual Studio and Web Matrix. You know, we're always looking at getting a better JavaScript experience in those editors, so you can write applications in there as well. The third thing on the list is fairly interesting. So today, when you work with Azure, it's sort of a Microsoft-centric platform. All our tooling is pretty heavily Microsoft-focused, and then even the command line tool that I showed is PowerShell based, and PowerShell itself only runs on Windows. So we're always looking at ways to actually expand the reach of Azure beyond the PC. So if you can go ahead and deploy from a Mac, like that would be a really cool experience. And so we're thinking in the direction of possibly creating some sort of deployment experience similar to PowerShell that would work on the Mac as well. Moving on to the next item, when you host an application in Azure today, IIS Node offers you a bunch of pretty cool features when it comes to logging and debugging. I mentioned you have Node Inspector and all that. But we can always do better, and so that's an area we're looking at spending more time in. Now, when it comes to the PowerShell stuff, of course, there's more we can do. I showed you a few of the commands, but there's always more that we can add. So there's a few settings that you can actually control in the web role itself that we don't fully support from PowerShell today. So that's an area where we're looking at improving as well. I see a question on Twitter. What development environment are you using for the project source walkthrough? I hope you're asking about this environment which I was using. This is actually Sublime Text. Like I said, it's a free project on the internet. It's actually quite good. Supports syntax highlighting. It's quite popular on the team. A lot of people use it. But we'd love to get a similar experience in Web Matrix or Visual Studio or something like that. Great. So I was talking about the improvements in the PowerShell commands, or I was looking at adding more. Again, the more Azure NPM packages. I only showed a few of the packages we support today, and so we're always adding more. So let me go ahead and actually jump to the GitHub repo where we do all that work. So you can go, if you go to github.com/Windows Azure, that's basically where the entire team contributes the source, and so we can actually do Azure SDK for Node. And this is basically where all the packages are hosted. And this is an open source project, which actually takes contributions, which is kind of a new thing for Microsoft. So we're always looking at adding support for more Azure services. And if you actually want to go ahead and volunteer and add an Azure service for us, we've taken contributions before. You notice kind of the cadence is actually, the cadence of releasing is actually very quick. We pushed 3 days ago for the last time. So it's kind of this new sort of collaborative development process that we're really encouraging. Let me also point your attention to the issue tracker itself. As embarrassing as this is, basically all our bugs are listed here publicly, and you can go ahead and file a bug against us, as you see people are already doing. I encourage you to go and try and play with this and So let me take a question from Twitter. Taking into account the partnership between Microsoft and Joyent, can we expect any integration with VS? So I'm not actually familiar with this partnership between Microsoft and Joyent. You probably mean the fact that we're collaborating on Node and kind of Node has now come to Windows. I take it that's what you mean. So if that's what you mean, then I mean, yeah, we're always looking at improving Node on Windows. I can't commit to any new work in VS. But yeah, I mean, we're always looking at improving the JavaScript editor experience. You're probably seeing some of the new work in the Dev 11 beta. We're always trying to make that better. Let me take another question. Is there something for access control on Node.js for Azure? Currently, in our repo, we actually don't have a dedicated package to talk to access controls to the access control service. The interesting thing here is that actually the community has stepped up and filled that gap. It's not official, but I've used this package before. Actually, that's the package I used in my application itself. So if you look at this every auth package, it's actually up on GitHub. And if you scroll down to the list of supported authentication providers, you'll notice Facebook right at the top, which is what I was using. But if you scroll further down, you'll actually notice right near the bottom here, actually Windows Azure Access Control Service is actually one of the supported packages. So we didn't have to do anything just by sort of using OAuth and using kind of the community accepted standards. They just went ahead and built a auth provider for Azure. I'm not saying we're not going to do something to try and get it even better, but as you see, the community sort of come in and stepped up and filled the gap at that point. I'll take one more question. Will Node.js Azure libraries transparently handle retries due to transient failures similar to? Okay, yeah, that's a great question. So basically, the question is, imagine one of the operations to Azure actually goes ahead and fails. Will we build in sort of logic to retry or something like that in the libraries? That's something we've talked about and we've decided against. We've wanted so far to keep our libraries as close to just simple HTTP wrappers as we can. So far we've actually tried to stay away from that, but that's definitely an area where we're waiting for the community to maybe come and help out. Basically for maintenance reasons and cost reasons, I think we're trying to basically keep our libraries pretty bare bones and lean. But if, for example, a file upload is another scenario where it'll be really useful to build something that's able to chunk a file stream and put it up on Azure. I don't think we're going to build that as part of our libraries, but it's definitely something that you can go ahead and build. It escapes me right now, but I think there's already a project out there that's using that uses our Azure project and builds on top of that and adds those features. So if you leave me if you send me an email, I might be able to respond and add that. But yeah, I think it already might even be there. Let me take one more question. Is there going to be any support for cross-platform deployment for Linux? Right, so this brings me back to my list of features here. I mentioned Mac. Yeah, of course, Linux is also on the list. We'll try to, if we decide to pursue this item, we'll definitely try to get as broad reach as possible. Try to use some open cross-platform technology to get to all these platforms. So yeah, I mean, by all means, that will be something that we'll think about. Okay, if there's any other questions on Twitter, let me keep going down here. So I talked about the npm packages. Showed you the site. If we talk about the support for native npm modules, that's an interesting one. If you want to actually use some of the operating system functionality from inside of a Node package, you can go ahead and do that. But currently, I think the story is a little bit messy. You need to also install a compiler on the machine. So we're always looking to see if we can improve that. And then the last item there is kind of providing more prescriptive guidance around how to actually write Node applications for Azure. So, say your app fits within one of a few canonical scenarios, like you're writing a chat application. or like a CRUD application. We're thinking of putting out templates out there or something on our GitHub page that's kind of able to get you started in a pretty seamless, straightforward way. So with that, I'm actually pretty much done with the content I prepared for you guys. I'll go ahead and take any questions, any additional questions that you guys may have on Twitter. Yep. So I think I'll just wait for any questions in Pete suggesting that I do a dance, which I will not do, but I can actually walk through some of the other projects that we have on our GitHub page while I wait for people to type any questions. So if we go to Windows Azure here, again, I already showed you the Azure SDK for Node project. Right, that's the, oops, sorry, I missed the Windows Azure here. Windows Azure. Right, so that's where the libraries live, and then Windows Azure SDK tools is where the PowerShell scripts actually live that I use to actually deploy to Azure. And then again, the windowsazure.com site is always there. If you go to develop and Node.js, there's actually the one-click big green install button that lets you kind of get set up with all the tools and a bunch of content and tutorials. So with that, I think I'm just going to wrap up. Thank you very much for joining me. Please go ahead and shoot me any feedback you have via email. Go check out our GitHub projects. Leave any feedback you have, file bugs, and go ahead and contribute. Thanks a lot.